All right, recordings rolling. It's Tuesday, April 14th. So we're gonna start the last module of the book today, module 11, which is matrices. All right, so here, I'll give you guys notes on these, and then I gave you guys a packet yesterday. It looks like this. If you didn't get one, then I do have some extra packets over here. All right, so we're gonna solve puzzles out of the book, or I'll have you guys do those for your assignments. Okay. Now, I did open a module 11 assignment on Alex, but that one's just extra credit. That gets labeled extra credit. It says extra credit. Because Alex did not have very many questions about matrices, so they're going to mostly be used in your book for a few weeks here. What is a matrix and how could this be useful? Okay, so the idea here is so think like an Excel spreadsheet. So we're looking at a rectangular array of constants, variables, or expressions arranged into rows and columns. Okay? So they can look like this. There's some real simple matrices. It's this matrix A right here. Actually, even that's more. Oh, here we go. Okay. Here's a good application of matrices. So what if you have these 5 different cities? You got New York, Los Angeles, Chicago, Philadelphia, Houston, and they have all these different aspects to them, all these different metrics. Yeah, they have different populations, different incomes, different house size, different rent values, maybe average rents. Okay? And you want to do a comparison or be able to crunch this data. Say you're an economist and you want to compare, like, oh, we've got these different cities have all these different variables and maybe what could affect them. Or what if we're going to have some policy and we want to see how does that affect uh, like so metric here, right? It's like, oh, okay, well, we know New York and Los Angeles passed on policy that maybe Chicago and Philadelphia didn't, so now we can start to tease that part of the data, right? When I was in college, it's one of my textbooks, right? Mathematics for Economists. Right? I don't even have a particular page linked here. If you just open this, you'll just start seeing lots of matrices, right? Guys, look right here. I set up equations. These are looking like matrices right here. Okay. Guys, look at all of it. Right? You're talking about matrices. You just flip a random part of it. So if you have lots of dimensions that you're trying to make sense of in equations, then matrices is a good way to do that. All right. All right. So so let's look at your packet here. Right. Now I went through the textbook examples at the beginning of the book and recorded those and put those on Google Classroom over the weekend. So guys, I'm going to give you guys notes on these 5 right here out of your packet. And then I'll have you guys do these for the assignment. And then we'll get to 11.2 tomorrow. 11.2 is also in this packet. So, and this packet is 11.1, 11.2. All right, so you guys good with what we're doing? You guys good? All right, so let's check out number 2. Number 2. Okay, so this is for notes. Okay, look at your packet. Does anybody still need one of these packets? So if you do, got some extra ones up here. So inventory, I got a pet store carries 3 brands of dog food. Each brand is available in 5, 10, and 25-pound bags, and the table shows each store's, those stores' current inventory. Right, so we have these 3 different brands, right, and then 5-pound, 10-pound, and 25-pound variations of each of those brands. Right. Okay, so it's like 9 different packages, right? Different brands, different sizes. Okay. Organize the data in a matrix. And so this is 2A. Okay. I'm going to make a 3x3 matrix. Okay, so go ahead and put these big brackets like this. Actually, the textbook I was showing you guys had parentheses, but more often than not, you'll tend to see brackets. Right? You see brackets. We're going to make a 3x3. Okay. And then really all I have to do is copy these numbers, but each row and each column is going to correspond to something. So there's going to be brand 1, they're calling it brand 2, brand 3. Right, so those are the rows. Okay. And then the columns tell you the size of the bags. We got 5-pound, 10-pound, and 25-pound bags. Okay. So it's going to go 2, 11, 8, 6, 5, 2, 14, 25, 16. Okay. And those are those 9 numbers that you guys just wrote in the brackets. Okay. Those represent the number of bags on the shelves. Okay. So it looks like brand 3 is really popular, or that they have a lot of brand 3, okay, at least on the shelf, right? Because there's a lot of those bags. or maybe not popular if nobody's buying it. One way or the other. Okay, so that was question A. Organize the data in a matrix. That's the matrix. Okay, you guys go with the matrix. Again, it looks a lot like just an Excel spreadsheet. Add the elements in each row and interpret the results. Oh, okay. So let's go row one. So maybe I'll say like the sum of x in row one. Okay. Isn't that 2 plus 11 plus 8? Is that 23? Okay. Sum of the elements in row 2 could be 6, 5, and 2, which is like 13. And the sum of row 3 got 14, 25, 16. Let's see, what is that? 14, 25. That's like 55, right? And each of these numbers represents. Wait, guys, what do you think each of these numbers represents? Yeah, the total number of bags for each brand. Okay. So we have 23 bags that are brand 1, we have 13 bags that are brand 2, and 55 bags that are brand 3. Okay. Regardless of what size, are they small bags or big bags? Okay. We just spoke about that, right? Okay. All right. Okay, that was part B. Okay. So we got part A, part B. Part C. What does the element A22 mean? So, guys, in matrix math, whenever you see a lowercase a like that, they're referring to one of these elements, one of these 9 elements. There are 9 elements here. Okay? And that subscript 22 tells you basically go like second row and second column. Okay. So A22 would be 5. Is that go down to there? Okay, let me give you guys a few of those because if you see like A13 or A31, that's different from each other. And then A22 is what they asked for. Okay. So guys, 1-3 refers to first row, third column. Right, so you go first row and then third column. That'd be 8. Okay, that'd be 8 bags. 8 bags. 3-1 is like third row, first column. That's 14 bags. And then 2-2 is guys, what do you think this is right here? 5. Yeah, 5. Okay, that was question C. You guys are right with that. All right, question D. Would finding the mean of the elements in each column provide any meaningful data? Okay. So now we're going to switch from looking at rows to looking at columns. Like, here, guys, how about these 3 numbers right here? If I took the average of those 3, what would that represent?
The 5-pound bags or less.
Yeah, that's it. Okay. So each column average, right, the average of the elements, represents the average number of bags of that size, regardless of brand. Yeah, like I'll say per brand. Right. Like for example, if you do 2 plus 6 plus 14, and then divide that by 3, say that's 8 plus 14. Okay, that'd be 7.33. That'd be 5-pound bags on average per brand. Right. So about seven bags on average per 5-pound bags. All right, you guys go there. Good there. All right, so guys saw looking at different metrics within different cities. We're looking at different bags of pet food on the shelf. Right, you guys ready for something a little more abstract? Right. I got two down here. I'm assigning you guys number 5, and we're going to do number 4 for notes, but they're really similar to each other. Okay. Create an incidence matrix for each graph. Ooh. Right. So what we're looking at here is, you guys see these 4 vertices and the 5 connecting lines? You guys see that? Right. 4 vertices and 5 connecting lines. Okay. How can we organize what's connected to what? And the vertices are labeled A, B, C, D, and the connecting lines are labeled 1, 2, 3, 4, 5. So, guys, in this case, 1, 2, 3, 4, 5 are like the names of the lines. Okay, so we did that. Okay. Okay, so here I'm going to redraw that picture and then create a matrix to represent that. So we're looking at this diamond shape. We got vertex A, vertex B, vertex C, vertex D. And then the connecting edges go 1, 2, 3, 4, 5. Right. All right. So since we have 4 vertices and 5 connecting lines, I need to create I'll suppose a 4 by 5 matrix. 4 refers to the vertices. 5 is the well, I'll call it edges. Okay, I might say it like that. So you need a 4 by 5 matrix. So set up a big old matrix, big old set of brackets. So we'll be doing a point A, point B, point C, and point D. And then these edges here are labeled 1, 2, 3, 4, 5. So those are the names of the edges, 1, 2, 3, 4, 5. Okay. And this is going to be an incidence matrix. All right, you guys good so far with the setup? Good. All right, so let's start with point A. All right, this point A is connected to edges 1 and 4. You guys that? Okay. So for A1 and A4, I'll put 1s for each of those because those apply. Okay. But point A is not at all connected to 2, 3, or 5, so I'm going to put 0, 0, 0, and 0 those out. How about point B? What?
5 and 2.
Yeah, 1, 5, and 2. So 1, 2, 5 here, and then zeros on the others. Okay. What? Go ahead. What do you think for C? Yeah, 2 and 3, and then zeros for everything else. And then how about point D? Yeah, 3, 4, 5, zeros, not everything else. Okay. Or you could have gone by columns, look at the edges. Okay. Let's just check out a couple of these, make sure they work. Okay. Like, according to this matrix that you guys just made, that tells you something about edge 3. It says it connects to point C and D. Is that true? Yeah, 3 does connect to C and D. Okay. In fact, guys, every single one of these edges connects to how many points? Exactly 2. So should you get exactly 2 1s and 2 zeros in every single column? And you sure do. You sure do. Okay, the last one. Okay. All right, is that okay? Okay. Instance matrix. All right, that's good. That's good. All right, do a few more with you guys here. All right, number 6. So state the dimensions of the matrix and find the indicated element. So we have, they're calling it matrix A. We got bracket -9, 3, 5, 10. Okay. And they want you to find A1, 2. 1, 2. Okay. All right, so I would say this is a 2 by 2 matrix. Okay. This is the first 2 is the number of rows. The second 2 is the number of columns. Okay. And A1, 2. Okay. Guys, first row, second column. What element is that? Huh? First row, second column?
3.
Yeah, 3. There you go. A12 is
So answer.
yeah, that's the whole thing. Right, you guys got it on number 6?
Yeah.
So, that's it.
Because they're okay.
Okay, number 9, which well, I also had circle for your homework, but yeah, we'll just do it here. It's a good example. Nutrition labels show facts about whole milk and skim milk. So here's your whole milk, and here's your skim milk. We've got different nutrition facts. Create a matrix to compare the calories, sodium, and milligrams, carbohydrates and grams, protein and grams for both types of milk. So they're giving you the units, we can just put the numbers in the matrix. Okay. Now, we're doing 2 different kinds of milk, whole and skim. And then we have, let's see, calories, sodium, carbs, protein. That's 4 different aspects. Okay. So we need to either create a 2x4 matrix or a 4x2. And I think you can go either way. I'm going to create a 2x4 about that. Okay. So we create a 2x4 matrix. So it's going to go like this. And for the rows, let's go whole versus skim. Okay. And for the columns, let's do this nutrition aspect. So we had calories. We had sodium in milligrams. So sodium and milligrams. We had carbs in grams. And protein in grams. Protein and grams. Okay. You guys got that set up? Okay. All we're going to do is just take the information off these labels and turn them into a matrix. Okay. So let's start with whole. Whole milk has 150 calories. 150 calories. Okay. You guys tell me, how many calories does the skim milk have? 80. Yeah, that's right. Right there.
Nope.
How many calories? Okay, so you guys know how to find how many calories? Okay, sodium. Whole sodium, I'm looking at 125 milligrams, so I'll put 125. Okay. And how about for the skim milk? What would you say? 130. Huh, interesting. Actually has a little more. Huh, okay. All right, let's go carbs. Carbs, I'm looking at 12 grams on the whole. Okay, how about for the skim? What is it?
Looks like.
Yeah, also 12. Yeah, 12 and 12. Okay, so that's the same. Okay. Then protein, I'm looking at 8 grams on the whole. How about for the skim?
Also.
Hey.
Yeah, also 8 grams. Okay, so it looks like the biggest difference. Yeah, and see, like if you're trying to pull the data off these labels, it's like, okay, you have to dig around for it. Right, it's okay. But in a matrix, the numbers just pop out. So it looks like the biggest difference is definitely the number of calories. Skim has almost half the number of calories. Okay. Sodium is pretty similar. Interestingly, skim has a little bit more sodium. Okay. Then all the other metrics is actually identical. So you guys good with the milks?
Yeah.
Let's do one more. One more. Number 15. Yeah, 15 here. Okay, so we got this matrix is equal to this matrix. Can you solve for x and solve for y? So we got 32 5x. That matrix is equal to this matrix. Okay. Okay, so here's straight out of the book. There's 32. Okay. All right. Well, I think what I can do is say 4y squared must be equal to 32 and solve for y. And all right, so let's do it. So divide both sides by 4. Y squared is 8. So y could be the square root of 8. Yeah. Maybe plus or minus. Here, you don't like it. And how about for x? 5x could be 15. So then x is equal to what? 3. There you go. All right, that all right? All right, so lesson 11.1 is just introducing you guys to matrices. You know, it looks a lot like Excel spreadsheets, I think. Yeah, how to organize rows and columns and find elements. Yeah, so that's about it. Okay. And then in the later lessons, we're getting the math is going to get more and more interesting. All right, so we'll be doing more of this later. All right, so you guys double check, make sure your name's on your notes. Guys, your name on your notes, name's on your notes. So go ahead, turn those in the grade tray, and I'll give you guys points.